Very good afternoon, friends. I am Karthik, and today we are going to learn one of the important topics in control systems, that is frequency response analysis. So, in frequency response analysis, one of the important topic in this is nothing but Bode plots. What exactly can we get using the Bode plot? The main intention of Bode plot is nothing but to find the magnitude versus phase. Magnitude, which is represented by A generally, and phase angle, which is represented by phi. So in Bode plots, we are going to find the graph for magnitude and phase angle. Generally, let us take an example. Let me give you an example and explain you. Example goes like this. G of s is nothing but the transfer function is s square by 1 plus 0.5 s into 1 plus 0.05 s. Generally, the transfer function need to be in the order of 1 plus tau s1 into 1 plus tau s2 and so on, so that we can continue that finding out the Bode plot. Now we can see in this question 1 plus tau into s1, 1 plus tau into s2, so it is in the correct order. Then we can proceed now. Now let us find the first step is always when you're having it in a proper order, substitute s is equal to j omega. This is the first step. Wherever you have s, substitute. Now see in the transfer function, g of j omega is substituted by s is nothing but j omega whole square by 1 plus 0.5 j omega into 1 plus 0.05 j omega. Now let me draw a table for a term, then corner frequency, slope, and change in slope. So I have drawn, and now see the first term is, you can see here, right, j omega whole square. The next term is 1. Always remember it is in the denominator form. Don't forget the denominator form. 1 plus 0.5 j omega. If you don't write the denominator form, you would get the different answer. 1 plus 0.05 j omega. These are the three terms that we are finding here, and I'm writing these in the terms. So the first corner frequency is always represented by omega c, and it is given in radians per second, and slope is usually given in dB, and change of slope is also given in dB. Remember this one. And now the corner frequency of the first one is nothing. So slope, see, always remember this is in the numerator root. So numerator and the order is 2. So if the order is 2, it is 20 into second order into 2. So it is 40. Because it is numerator, so I am taking it positive, plus 40. Now see, it is in the denominator form, and the slope is minus 20 because it is in the denominator, minus, and order is 1, so minus. In the similar way, this is in the denominator and the order is 1, so it is minus 20. Now write the change in slope. So how we calculate the change in slope is nothing but, leave the first one. So in the second one is, there is a change from positive to negative sign. So we are writing, whenever there is a change in positive to negative, we add these slopes. 40 minus 20, that is nothing but 20. You understand, there is a change. We are going from positive to negative, so we are having a negative sign. Now this one comes here in the next step. So it is 20, and this is positive, this is again negative, so 20 minus 20, that is nothing but 0. So slope 1 is 20, and slope 2, change in slope 1 is 20, change in slope 2 is 0. and corner frequency is omega c1 is nothing but 1 by 0.5, that is nothing but 2. This is 0.5. Omega c2 corner frequency 1 by 0.05, that is nothing but, you get 20. Now we need to find the magnitude of various corner frequencies. Let me write magnitude of various corner frequencies. So always remember that we are going to have omega L, that is nothing but lower frequency, and omega H, that is the higher frequency. So here omega L is nothing but lower than this one. See what is the what we are having here, it is 2 and the higher one is 20. Lower than 2, let us take 0.2, and omega 1 is nothing but this one, this frequency, that is 2, and omega 2 is nothing but 20, and omega 3 is nothing but, not 3, we need to write omega higher frequency. So I am taking here omega H as 100. You can take 50, you can take 60, any value depending upon yours. So now we need to find magnitude A. So the first term here is j omega square. So the formula is, for the first, I'm finding now the magnitude. I'm finding the magnitude for the first one, that is magnitude for lower is 20 log modulus of j omega, this is whole square rhos. Substitute the value in this, 20 log mod of 0.2 whole square, you calculate, so you get minus 28 dB. In a similar way, next one, omega c1, I'm calculating, magnitude can be taken as AC1, formula 20 log modulus of j omega whole square, so it is 20 log, what is the value here for this is 2, so in place of this substitute 2 whole square and you are going to get 12 dB. Similarly, see, there's a formula for this. So the formula is AC2 can be written as slope from omega c1 to omega c2 into log of WC2 by WC1 plus magnitude of AC1. So slope of omega c1 is nothing but, you can see here, so it is, the change in slope is nothing but 20 into log of omega c2 by omega c1 is nothing but 20 by 2 plus AC1 is nothing but 12 dB plus 12 dB, you get 20 by 2 is 10, so you get 32 dB. In the similarly, AH is the same formula, slope from omega c2 minus omega h, to omega h into log of omega h by omega c2 plus AC2, the formula. So omega, the slope from omega c2 to omega h is nothing but 0. So the calculation will be easy, because anything into 0 is 0, plus only AC2. AC2 is 32. So you get AH is 32. Now draw a table for the noted ones. So this is omega W and A is the magnitude. So I'm writing the values. See, the first one is 0.2, the second one is 2, 20 and 100. I have taken, please go back through my previous ones, 2, 20 and 100, and what we have got is minus 28 dB, and this is 12, and this is 32, and this is 32. These are nothing but the magnitudes. Magnitude. Now let us find the phase angle. Phase angle, phase of g of j omega is nothing but j omega square from the question. So remember formula, 180 minus tan inverse, what is omega in the question? 0.5 omega, and tan inverse of 0.05 omega. So draw a table for similarly phase frequency omega and phase angle phi. See, I'm taking various values like 0.5, 1, 5, 50, 100. You can take any values. So I think you know how to substitute the values. Just use your calces. So use your calces and find out in degrees. Okay, from radians to degrees, and note down. After calculating, I have got certain values. So I have got the angle of 164 and 148, and this has come around 45, this as minus 135, and this as 160. So now this I have got the magnitude graph omega A, frequency and magnitude A, and magnitude and phase angle. Now I'm going to plot this on a graph. Guys, please be very careful while plotting it on the graph. See, always remember you can find the numbers here 1, 2, 3, 4, 5, 6, so on. So always remember on the y-axis we are going to plot the magnitude. Always write the magnitude on y-axis. On an x-axis we are going to plot the frequencies. So this we are going to plot. See what we are having. We are having the frequencies ranging from 0.2 to 20, 100. So always remember the x-axis, this is called the decade. What we are calling? We are calling this as decade. Or see, I'm going to start now marking this first point. The first line is 0.1, and you can find the second one, right? Then it is 0.2. This is 3, 4, 5, so on. So you're going to plot like this. So where I'm getting this? This is 2, 3, 4, 5. This is 0.5, and this term, the last one, see the line, and this is 1. Then next you're going to get, this is 2, this is 3, this is 4, 5, 6, and this line is 10th, number 10, and this one, next one is going to be 100, and this one is 1000. So always remember how we plot the frequencies. This is the graph, and now we are going to plot the magnitude. Just see, always right there on y-axis we are having, see, just look at my table, and the table, the highest one is 32 and the least one is minus 28. So I'm taking in the frequencies of in the range of 10, 10. So let always plot the highest frequency first. So just give it a random 50, because I'm having 32 as the highest number, 32 as the highest one. So 50, 40, this is 30, this is 20, this is 10, this is 0, this is minus 10, minus 20, minus 30, minus 40. So see now just look at the graph which we need to plot. See, it is 0.2 is giving minus 28 dB. See, now see in the graph 0.2, and it is giving minus 28. So minus 28 lies around somewhere here at G. I'm sorry, I'm just putting the mark here. Okay, and the next one, see, the next one is 2. 2 is giving out 12. 2 is, this is 1, then this will be 2. 2 is giving out 12. This is the line, and this is 10. 12 comes around here somewhere. So I'm marking a point. And next value is 20 is giving to 32. 20 lies somewhere here, and it giving 32. This is 30, and okay, this is okay. Where am I? Okay, I'm sorry, I have marked 10 somewhere wrong here. Okay, oh no, I'm right. So this is 20, right? Okay, 20, and I'm giving 32. 32 lies somewhere here. So this one, and next one is 100. The 100 value, 100 is also giving 32. 100 and 32. Always use a scale for joining these points of magnitude. Please do very carefully, don't get confused. This is the magnitude. Similar way, the face. So always write here the least value. I'm having negative values also for plotting the face. So it is minus 150, minus 100, minus 50, 0, 50, 100, 150, and 200. So look at the face values. It is giving 0.5 is giving 164 positive value. 164, 150, 64 lies somewhere here. So 0.5, this one, and 1 gives rise to 148 somewhere here. 45, 5 gives me, this is 1, 2, 3, 4, 5, 5 gives me 45. This line is 50, and just below is 45, 45, and then this line, the next value is 50, gives rise to minus 35. 50 lies somewhere here, and it gives rise to minus 35. This is 50, and below this is 35, minus 135, I'm sorry, and this is the 100, and gives rise to 150. So you can write it here. So just mark these points. Okay, for face angle, you can just plot it with the free hand. No need to use the scale. Face angle 5. So this is the magnitude graph, and this is the face angle. Thank you so much for watching my video. If you have any doubts, please leave the comments, and do subscribe, like, and comment on my page. Thank you so much. This is Karthik. Bye bye.